Hey, welcome back to QM6 part 2. We've done ands, we've done ors. Now we've solved and then graphed. Now we're going to take those graphs and figure out what the inequalities are from this. So let's see what this says. Write the compound inequality shown by each graph. I have this graph right here. And this graph is saying that I've got two inequalities, but they're going out. And I know that ors go out. So this is going to be an or right away. We know it's going to be an or. I'm going to have x that's going to be at least less than something and x that has to be greater than something. It might be equal to. We'll figure that out in a second. I come over here. Let's look at my less than one. Oh, that point is a filled in point. This is x is less than or equal to -1. Or x is greater than, no, that's filled in too. So this is greater than or equal to 7. That is all we're trying to do. Just write the compound inequality from the graph. Just write the compound inequality from the graph. Okay. Let's look at the next one. Let's look at the next one. Okay. This I know is an and. I know this right away. I know this right away because it's going in between. There's no arrows pointing out. This is an and. Pay close attention because I love how these work. I love how ands work. I love this compound inequality in one line. Since it's an and, I know I've got x. X has to be bigger than something and less than something. I start with that every time. I start with that every time. Okay. So if I start with that every time, I'm going to go ahead and just move. Oh, that's the bottom. I'll start with that. It's less, there's greater than something and less than something. Well, it's going to be greater than 0, but it also can be equal to because that is a filled in point. So I read this as 0 is less than or equal to x. And then my biggest value over here is 6. And that's an open circle, so I leave that alone. And I'm done. This says right here that x is somewhere between 0 and 6. It can equal 0, but can equal 6. And we're done. And we're done. Okay? For ands, always start with this. Write the compound inequality shown by each graph. Guess what? Pause. Because it said your turn. Hope you paused. Okay. I'm looking at number 9. Number 9 right now. That is an and. I know that for sure because it's going in. There's no arrows pointing out. This is an and. So I'm going to start by writing x that has to be greater than something. So that's why I have it like here. And then x has to be less than something. The number on the left is -8. That's the lowest it could possibly be. And it can be equal to it. It cannot be equal to it because that's an open circle. I'm done. On the right-hand side, I have the biggest number, which is -3. And I'm looking at this. Oh, it can't equal -3 either because it's an open circle. And I'm done. And I'm done. This is an and I'm done. Number 10, I'm looking at it. It's going out. Ors go out. So guess what? Right away, write an or. X has to be less than something. X has to be greater than something. Again, might be less than or equal to, might be greater than or equal to. We need to check. Let's look on the left first. It says my number is -4. So less than -4. And that's an open circle. So I will not put an equal sign there because it's just less than. On the right-hand side, X is greater than 2. But it can equal to because that is filled in. This is greater than or equal to 2. I'm done. I'm done. Okay. Let's take a look. Let's take a look at the last part here. We have expressing acceptable levels with compound inequalities. That's a lot of words to say. It makes sense because we wrote it down as a word problem. Okay. Quality control. This one says we need to write the compound inequality and then graph the solutions. The recommended pH level for swimming pool water, oh, swimming pools, what's that like, is between 7.2 and 7.6 inclusive. This inclusive business, this means it could equal. could equal 7.2 and 7.6. So if I'm going to write this inequality, I've got this pH level. We'll call P the pH level. Don't pee in the pool, all right? In other words, the lowest it can be is 7.2. The biggest is 7.6. The pH level has to be greater than 7.2, but could be equal. But it also has to be less than, but could equal 7.6. We just drew that, or we just wrote that from what makes sense. Okay, and we should graph the solutions. Yeah, closed circle 7.2, closed circle 7.6, and somewhere in between. It's not going to be bigger than 7.6. It's not going to be less than 7.2. Wait, less than 7.2, greater than 7.6. There we go. All right. Let's look at part B. Let's put part B. The recommended free chlorine level for swimming pool water is between 1.0 and 3.0 parts per million inclusive. There's that inclusive again, means or equal to. There you go. That's 11 reflect or equal to. Let C be the chlorine. Like I said, we're math people. We don't get super creative, right? C is chlorine in the pool. In other words, it's going to be between. If it's between, we know right away that's an and statement. So I'm going to take this C. C has to be bigger than something, but also less than something. But we said inclusive. We did say inclusive, so it could equal these two numbers. The lowest number is 1.0. The biggest number is 3.0. And guess what? We've already written it down. That's our compound inequality. Now we can graph the solutions. 1 is less than or equal to C, which is less than or equal to 3. Or equal to means I'm putting closed dots at those points, and an and means I'm going in between. Time to do the your turn. Inclusive, we said, meant equal to. Time to do the your turn. Hit pause. And now you're back. Write a compound inequality to represent the indicated quality control level and graph the solution. The recommended alkalinity level for swimming pool water is between 80 and 120 parts per million, inclusive. I'm going to get real creative here. For alkalinity, what's a good one? Good, very A, yeah, creative. A. Whoa, that's a really bad A. A. I know because it says inclusive. A is going to have to be bigger than something and less than something else, but it could be equal to because it says inclusive. The lowest value is 80. The biggest value is 120. We're done. Well, that part. Then to graph it. The lowest part is 80, but it could equal 80. The biggest part is 120. It could equal 120. And somewhere in between. There we go. There we go. That's your guided notes for QM6. Check on Google Classroom for what your practice 1 is. Take care. Have a great day. Go Aggies.